Hi everyone. Today we are going to cover probability. So we're going to define and use probability. So if you guys notice, there are going to be word problems, but it's a very simple process. The ones on the front side are going to be a lot more simple than the ones on the back, which are a little more complex. But we'll get through this together. So let's go through the first section. Let's go and define probability. Of course, all of you guys have a highlighter with you, correct? So probability of an event, the probability of an event is a number between 0 and 1 that indicates the likelihood that an event is going to occur. So how likely is an event to happen? So if you guys all of you guys have flipped a coin. So it's how likely is it for us to get tails. That deals with probability. Now, probability can be expressed as a fraction. It can be expressed as a decimal. And it can also be expressed as a percentage. Now, because you guys are not able to use calculators for this chapter, we are going to be expressing them as fractions, which will make it a little bit easier. You just have to make sure that you reduce your fraction. Now, the probability of an event, if it's not going to happen, we know it's going to be 0%. If it will happen for sure, the probability will be 100%. And right in between will be 50%. Now remember, if 50%, if we express it as a decimal, will be 0.5. And if we express it as a fraction, it will be 1/2. So probability can be expressed as a fraction, as a percentage, or as a decimal. Now the definition of probability. The probability that event A is going to occur. So if we're looking for event A, it's going to be over the desired outcome over the number of possible outcomes. This, on the numerator, we're going to have what you want. What are you looking for? That'll be on the numerator. On the denominator is what's possible. What are the different possibilities? So on the numerator is what you want, what you're looking for, over what is possible. So let's start with example 1. Example 1. You roll a 6-sided die. So we have a 6-sided die. And I have one right here, which are numbers 1 through 6. We have the number 1, number 2, number 3, number 4, number 5, and number 6. Find the probability of rolling a 4. So the way we're going to place the notation is the probability of rolling a 4. That's what we are looking for. Probability should end up with a fraction. So we're going to have to fraction. On the numerator is what you want. You want a 4. So let's see, how many 4s are in the die? We have how many 4s? Can't find any. Where is it? That's right. There's only one 4. So there's only one 4. That's what you want. Now the denominator is what's possible. How many numbers are possible? 1, 2, 3, 4, 5, 6. There are 6 numbers are possible, so it'll be 1/6. And simplified. Now, if we want to convert it to a decimal, we'll just do division, and we can also convert it to a percentage. For now, a fraction will be perfect. Letter B. What's the probability of rolling an odd number? So probability of an odd number will be a fraction. Probability should always give you a fraction. Let's see. on the numerators, what we want? We want odd numbers. So how many odd numbers do we have? We have the 1, the 3, and the 5. So we have 3 odd numbers over how many different possible numbers can we have? We have a total of 6. And we can rewrite it as a fraction, which will be 1/2. And if we convert it to a decimal, it will be 0.5. If we convert it to a percentage, it will be 50% chance. But in this case, 1/2 will be perfect. Letter C. Rolling a number less than 7. We are looking for a number that's less than 7. So let's place in the proper notation. Probably the number is less than 7. I'm just going to use my inequality. And this will be a fraction. On the numerators, how many numbers do we want? We want a number less than 7, which are 6 numbers are less than 7. And how many numbers are possible? 6, which is equal to 1, or 100%. We also going to be covering independent events and dependent events. Now, independent events means that we are having 2 events that will not change the outcome from one to the second. Dependent event means that the outcome of the second one depends on what happened first. For example, if I toss a coin and it lands on tails, that's heads, that's tails. If it lands on tails, that's probably that lands on tails is 50%, correct? Now, if I flip it again and it lands on tails again, what's the probability that it's going to land on tails? It's going to increase or decrease? Now, we already have 2 tails. So if I flip it again, what's the probability that's going to land on tails again? And lands on tails again, so it's 50%. So if I flip it again, will the probability change? Lands on tails again. So will the probability change? No, right? The fact that we already got 3 or 4 tails, if I flip it again, the probability that it's going to land on tails is still 50%. So therefore, the probability does not change. It doesn't matter what happened before. This type of probability is independent because the fact that I get tails the first time, the probability does not change for the second time. Dependent, what happens on the first one will change what happens on the second one. So that's it. Example number 2. You toss a coin 3 times. So we're going to toss a coin 3 times. What's the probability? So here is our keyword. I want you guys to highlight it and circle it, because probability, that means that we are going to end up with a fraction. That the coin lands on tails 3 times in a row. So we want tails 3 times in a row. Let's write down the notation. We want the probability of a tail, then another tail, then another tail. What's the probability that's going to land on the tail on the first time? What's the probability that's going to land on tails? Will be, it can be heads or tails, so it'll be 1 out of 2. That's for the first one. And, so multiply. What's the probability that's going to land on tails again, the second time? It's going to be 1 over 2. And what's the probability that's going to land on tails again? The probability that's going to land on tails will be 50% again, so 1/2. And we multiply across. 1 times 1 times 1 is 1. 2 times 2 times 2 will be 8. So the probability that lands on tails 3 times will be 1 over 8. Now, let's go through the next problem. It says, a bag contains 5 pink, 4 yellow, and 2 green. So we have 5 pink, 4 yellow, and 2 green balls. If the balls are selected a random, one after another, what's the probability that the first two balls are yellow and the third one is green? So we're looking for first two yellow and the third one will be green. So let's see, we have 5 pink, 4 yellow, and 2 green. What's the probability that you're going to get 2 yellow? So the first one we're looking for 2 yellow, and the third one we're looking for a green without replacement. So without replacement, that means that we're going to have them all mixed up. You're going to go in there without looking, of course. I'm not looking. Without looking, what's the probability that's going to be a yellow? Without replacement, that means that you're going to place it inside your pocket. You're not going to place it back into the pile. You're going to leave it on the side or inside your pocket. That means without replacement. With replacement means that once you select a yellow one, you place it back, you mix it up once again, and then you go back and select. So without replacement means that you're going to place it inside your pocket. With replacement it means that you're going to select it and then you're going to replace it. Now let's write down the notation for this. What's the probability of getting a yellow, and the last one should be a green? First, what's the probability of getting a yellow one? That'll be the first fraction. Remember, on the numerator will be what you want, on the denominator will be what's possible. First, what's the probability of getting a yellow one? So if I go in there without looking, so I'm going to cover it up, and what's the probability of getting a yellow one? And yes, I got a yellow one. What's the probability of getting a yellow one? How many yellow ones are possible? Are what you want? You want 1, 2, 3, 4. There are 4 yellow. Over how many of them are possible? There are 5, 9, 11 possible. So let's assume that you got the yellow one and you place it on the side. So that one is no longer counting. Times. We're looking for another yellow one. So what's the probability of getting another yellow one? So we go in there. How many yellow ones do we have? 1, 2, 3. And how many of them are left? We have 3, 4, 5, 6, 7, 8, 9, 10. Remember, we have 10 because we already took one out. So that one is no longer counting. So there you go. Let's assume that you go in there and you take a yellow one. Very good. So now we're going to place it into the side. We're not going to replace it. Now what's the probability of getting a green one? So how many green ones do we have? 2. You want a green one. But how many of them are possible? 9. And now we just simplify. Now before you multiply across, it's best to simplify. So let's see, what can we simplify? We can simplify the 3 and the 9. This becomes a 3. We can simplify the 10 and the 2. This becomes a 5. So we have a 4 on the numerator. And then we just multiply 11 times 5 times 3. 11 times 5 is 55. Then we multiply by 3, which would be 15, carry 1, 15, 16. 165. So the probability of getting a yellow, and green will be 4 over 165. Now, what's the probability of getting the same thing? What's the probability of getting a yellow, and a green, but with replacement? So we are going to have the same amount. We are going to have 5 pink, 4 yellow, and 2 green. And we're going to mix them up. What's the probability of getting a yellow one the first time? Now, how many yellow ones do we have? Which is what we want. 1, 2, 3, 4. So 4. Even though we're only selecting 1, how many yellow ones are there? 4. How many of them are possible? 11. So we go in there, we are not looking, we select a yellow one. Now, with replacement, so now that we select it, we're going to place it back in there and we're going to mix them up again. So what's the probability of getting another yellow one? Probability of getting, how many yellow ones do we have? 4, still, because we left it behind. We replaced it. So, and how many are total? 11 once again. Times. So we go in there, probability of getting a yellow one is 4 out of 11. And yes, we get a yellow one. And we place it back. Now, what's the probability of getting a green one? Will be 2, because we have 2 green, over 11 once again. Very good. So we just multiply 4 times 4 is 16, times 2 is 32, over 11 times 11 times 11. So 11 times 11 will give me 121, and multiply by 11 gives me 121, 121. That gives me 1, 3, 3, 1. So 1, 3, 3, 1. And that's the probability. Now, if you need to convert it into a decimal, then you'll just type it into the calculator. And that'll be 32 divided by 1,331. And your percentage will be about 2.4%. Now, let's continue to the back side. Now, in example number 4, you randomly select 2 cards from a standard deck of 52 cards. And the cards are once again right here. Now remember that we labeled it on the last set of homeworks. What is the probability? So now we have probability. We know that our answer should be a fraction. So let's see. We are looking for the probability. Answer should be a fraction. That the first card is not a face card. And the second one is a face card. If you replace the first card before you selecting the second. So this is going to be with replacement. So we put on the probability of not a face. Then we're looking for the probability that's going to be a face card. And we are replacing it. So let's see, what's the probability that we're not going to get a face card? It's going to be a fraction. So you need to think, the numerator is what we want. How many non-face cards do we have? All of the ones that are non-face are numbers 10 all the way down to 2, including the A are non-face, which will be 40. So we have 40 that are non-face cards. How many total in the deck? 52. That's how many possible ways. And times. Now the second one is a face card. Remember, we took the card, we saw it, and we placed it back on the deck. So now, how many face cards do we have? We have 12. So we have 12 face cards. That's what we want. Remember, even though we only going to collect one, or we're just going to take one, how many possible of the ones that we want are there? There's 12. How many overall? How many of them are possible? 52 again, because the one that you took, you placed it back on the deck. And now from here, we just simplify. We are going to, let's see, they're both even, so I can divide by 2, that gives me a 6, that gives me a 26. They're even again, so I divide them by 2 again, that gives me a 3, and that will give me a 13. On the left, they're even once again, so I can divide by 2, so that gives me a 20, and that gives me a 26. They're even once again, so I'm going to divide by 2, so that gives me a 10, and that gives me a 13. And then I just multiply, nothing else to simplify, so I'm just going to multiply across. 10 times 3 will be 30. 13 times 13 will be 169. And that's the probability that the first card will be not face, and the second one will be face. Now, if I do the division on my calculator, 30 divided by 169 It's about 17% chance, which is pretty small. Let's continue with the next example. Now, the next few examples, all of them are going to be different, which is the thing that's challenging about this section. Example number 5. You and 2 friends go to a restaurant and order a sandwich. So let's see, how many people do we have? We have you and 2 friends. So we have a total of 3 people. There are 3 of you. The menu has 10 types of sandwiches. And each of you is equally likely to order any type. What is the probability? So we see the word probability again. Circle it. Now, just to remind you guys that probability, that means that you're going to end up with a fraction. What is the probability that each of you orders a different type of sandwich? So there's 3 of you guys. So let's say those are all 3 of you guys. So we have the probability, different sandwich. So there's 3 of you guys that are going to the counter. So there's all 3 of you guys that are going to the counter. And you're the one that's going to order first. You go over to the counter and say, I would like to order a sandwich. And then they ask you, well, what type of sandwich do you want? Now, and you're going to say, I just want something different from whatever they're having. Now, have they ordered anything yet? No. They're actually going to be way behind the counter because they haven't ordered anything. So for the first one, remember, it's what you want over the possible. Now, you want a sandwich that's different from them. How many different sandwiches are different from what they've ordered? All 10 of them, right? Because none of them have ordered yet. So how many of them are different? 10. Over what's possible? How many different sandwiches do they have available? 10. So let's say you go up there. So the probability that you get something different for the first person will be 10 divided by 10. 10 of them are different so far because they haven't ordered. And 10 of them are available. And you say, no, let's see, I would like to order the ham and cheese. So they order the ham and cheese, and okay, thank you, and then you just go over to the side, and you walk over to the side. Then the next person comes up and says, I would like to order a sandwich. And they ask you, what type of sandwich would you like? And you say, well, it doesn't matter, I just want something different from whatever they're having. Now, so far, he ordered the ham and cheese. How many of them are different from the ham and cheese? 9, correct? 9 of them are different so far. How many of them can you order? Now, he ordered ham and cheese. Are they out of ham and cheese? No. They still have all 10 available. So it'll be 9 over 10. And you say, well, I would like to order the tuna. And you get the tuna and you go to the side to eat it with your friend. So ham and cheese and tuna. Now, the last person goes up and says, I would like to order a sandwich. And they will ask you, what type of sandwich would you like? And you say, well, I just want something different from them. How many different sandwiches are different from what they've ordered? Ham and cheese, tuna. So we still have 8 different types. How many are available for you to order from? Well, they still have tuna on the sandwich, on the menu, and they still have a ham and cheese. So they still have 10 different sandwiches. And from there, we just simplify. Does that help? So from here, we just simplify. So let's see. The 10 and the 10 cancels out. The 8 and the 10, I'm going to reduce it by 2, gives me 4. That gives me 5. So that gives me a 36. And that gives me a 50. And I can still reduce it by 2, correct? So remember, you should have reduced the 4 and the 10. But in this case, I'm just going to divide by 2, so it gives me 18 divided by 25. And that will be your answer. Now, if you do 18 divided by 25 on the calculator, just to be able to see the percentage, 18 divided by 25, it's actually 72% chance that all of you guys will get something different. That's pretty high. Number 6. You put a CD that has 8 songs in your CD player. And do any of you guys have CD players anymore? Probably not. You set the player to play the songs at random. So let's see. You have 8 songs in there. The player plays all 8 songs without repeating any of the songs. What's the probability? Probability again. So probability means that we're going to end up with a fraction that the same songs are played in the same order as they're listed on the CD. So instead of using a CD, so let's assume that you have your fancy iPhone, of course, nice and shiny, and you are trying to figure out, let's see, let's select an artist that I have. Let's see, which one should I select? Which one should I select? Lots of selection to make. Let's see. So let's say that we are artists. So let's say that we are going to select, let's go through the first one, Adele. And let's assume that we have only 8 songs. If we place them in order, this is how they're listed on the album. What's the probability that if I place them on shuffle, that they all get played in the same order? So probability of the same order. Remember, we're going to end up with a fraction. So I press shuffle. I'm going to shuffle it. And what's the probability that rolling in the deep gets played first? So let's see. This is what we want. How many rolling in the deep are available? Just 1. That's what we want. How many of them are possible? 8 of them. So for the first song will be 1 out of 8. So let's assume that rolling in the deep gets played. Oh. Yeah, we don't want to hear that. Let's say that one gets played already. The next one. Now remember, they cannot be repeated. So what's the probability that Rumor Has It gets played next? How many Rumor Has It are there? 1. How many songs are available? Remember, this one is no longer playable. So how many of them are available now? 7. Next one. So we want the next song to be listed to be played in the same order. So we're looking for turning tables. So how many turning tables are there? Just 1. Oops. 1. And how many of them are available? Remember, the first 2 can no longer be played because they cannot be repeated. So we have 6. And so on. So the next one will be, we want, Don't You Remember? Will be 1 out of 5. The next one will be 1 out of 4. Then 1 out of 3, 1 out of 2, and 1 out of 1 for the last one. Or many times you guys will see as 1 over 8 factorial. Now, you just multiply the denominator, and on the homework, if it's any of them like this big, you can just give me the answer as 1 over 8 factorial. 8 factorial will be 40,320. So notice that that's a very, very small fraction. Or I can just do 1 divided by 40,320. And that gives me less than, it's going to be, if I move it to decimal twice, it will be 0.002%. So a very small percentage that they all be played on the same order. Let's continue with the next. Now the next 2 problems will be very similar. On the next 2 problems, let's read it together. It says, Roman has a collection of 13 books. So you have 13 books. 7 of them are fiction and 6 of them are non-fiction. He randomly chooses 2 books to take with him on vacation. So he's going to select 2 books. What's the probability that he chooses 2 fiction or that he chooses 2 non-fiction? Now, in this case, notice the difference. So let's assume that we have, so these are your fiction and these are your non-fiction. Now, in this type of problem, we're not just selecting 1 and then another, or one fiction and then another. No, in this case, it's asking you to, if you go in there without looking and you just select 2, what's the probability that you're going to select 2 fiction or 2 non-fiction? So if you go in there, it makes them up, and you go in there and you just select 2. What's the probability that they're going to be 2 fiction or 2? So they're going to be 2 of the same type. In this case, we're going to have to use the choose. So you have probability of 2 fiction or 2 non-fiction. On the numerator, it's going to be like 2 different problems from the ones we were doing before. On the numerator is the ones that we want. We want it to be 2 fiction. So let's see, how many fictions are available? 7. And how many are we going to select at a time? How many do we want to choose? 2. So 7 choose 2. Or will be a plus. In non-fiction, there are 6 available. And how many are we looking for? We are just going to be selecting 2. Now, on the denominator, it's how many of them are possible. It doesn't matter what type of them are. How many of them are possible? 13. And how many of them are we selecting? We are only selecting 2 of them. So on the denominator will be the total and how many are we selecting. It doesn't matter the type. It's how many different combinations are there of 2. And from there we just simplify. I must simplify each of them separately. So 7 choose 2. That'll be 7 factorial over 5 factorial and 2 factorial. That gives me 7 times 6 times 5. And that's going to cancel with the 5 factorial. Correct? That cancels out. And then I still have my 2 and 1. I'm going to simplify the 2 and the 6 becomes a 3. So that gives me a 21. So it gives me 21 plus 7 choose 2. So it'll be 7 factorial over, is that 7? No, that should be 6. Because we have only 6 non-fictions. So make sure you guys fix that. That should be a 6, right? Did you guys catch that before? Perfect. So that'll be 6 factorial over 6 minus 2 will be 4 factorial multiplied by 2 factorial. That gives me a 6 times 5 times 4 factorial. That will cancel with my 4 factorial. And I still have my 2 and my 1. My 6 and my 2 cancels, and that becomes a 3. That gives me a 15. So plus 15 divided by 13 choose 2. So it'll be 13 factorial over 13 minus 2 will be 11 factorial multiplied by 2 factorial. So it gives me 13 times 12 times 11 factorial, and that's going to cancel with my 11 factorial. That cancels out. And I still have my 2 and my 1. Let's see, I can simplify my 2 and my 12 becomes a 6. So 13 times 6 will give me 78. And I just simplify, so it gives me 21 plus 15 will give me a 36 over 78, which is divided by, let's see, what number divides 36 and 78? I can divide by 6, so it gives me 6. 78 divided by 6 will give me a 13. So the probability that I get 2 fictions or 2 non-fictions is almost 50%, right? A little bit less than 50%. Number 8. Problem number 8 is very, very similar. It says, you are adopting 3 pets from the animal shelter. So we are taking 3 pets with us. When you arrive, you notice that they have 5 dogs and 4 cats. So they have 5 dogs and 4 cats. If you choose your new pets at random, so you're going in there, and let's see, we have how many? 5 dogs. Those will be your dogs, and those will be your cats. What's the probability that you choose 2 dogs and 1 cat? So we have probability, so we're going to end up with a fraction. We are looking for 2 dogs and 1 cat. Now, it doesn't tell you what is the probability of selecting a dog, then a dog, placing it in your pocket, and then a cat. No. It tells you that if you go in there and select them all at random, 3 of them, what's the probability of selecting 2 dogs and a cat? So whenever you have to select them, all of them all at once, then you have to use the choose. On the back, it tells you what's the probability of selecting 1, placing it in your pocket, and selecting another, placing it in your pocket, and taking another one and placing it in your pocket. That's different. Then that will be 3 different fractions. On this type of problem, they're telling you that you are selecting 3 of them. If you're selecting 3 at a time, then we have to use the choose, same thing as before. So probability of 2 dogs and 1 cat. Let's see. The numerator is what we want. What do we want? How many different ways can you select 2 dogs and 1 cat? So let's select the dogs first. So let's see. How many dogs are available? 5. How many are we selecting? 2. And so we're going to multiply. How many cats are available? So now select the cats, 4. How many do we want to take with us? Will be 1. The denominator will be how many different ways can you just select 3 animals? It doesn't matter if we get 3 of the same. So the denominator is what's possible, or what's possible basically. How many animals are available? 9. And how many are you selecting? 3. And from there we just simplify. So remember, the numerator is what we want, the denominator is what's possible. It doesn't matter if they're all 3 dogs or 3 cats or 2 cats and a dog. This will tell us how many different ways we can select 3 animals. We're going to simplify it, so let me just do it underneath so we have the space. 5 choose 2 will be 5 factorial over 5 minus 2 will be 3 factorial and 2 factorial. It will be 5 times 4 times 3 factorial will cancel with the 3 factorial. Those 2 cancels, so that canceled out. And I still have my 2 factorial, which is 2 times 1. My 2 will be simplified, so it gives me a 2, so that is 5 times 2 is 10. We have 4 choose 1. Remember, every time that you have a 1 in here, will just give me a 4. So it'll be 10 times 4 over 9 choose 3. So it'll be 9 choose 3. So it'll be 9 factorial over 9 minus 3 will give me 6 factorial and 3 factorial. And I'm going to expand it. 9 times 8 times 7 times 6 factorial over, I'm going to cancel it with my 6 factorial. That cancels out. And I still have my 3, my 2, and my 1. I can simplify the 9 and the 3. This becomes a 3. I can simplify my 8 and my 2. And this becomes by 2 divided by 4. Simple and multiply. 3 times 4 is 12. Times 7 will give me 84. So that will give me 84. So that gives me 40 divided by 84. And I'm going to simplify, so it gives me, let's see, then it should be divisible by 10, as by 4. So it gives me 10 divided by 4 gives me 21. And that'll be my answer. So this will be just slightly less than 50%. So go ahead and work on your objective met. On your objective met, let's work it out together. Okay, let's go and pause it. Try working out by yourself, and then I'll work it after. Go and give it a pause. You ready? All of you guys should have done it at this point. It says, a cereal company plans to place 4 new cereals in the market. their test analysis, so we are placing 4 new zeros. Their test analysis have produced 9 different zeros. 5 of them are multigrain and 4 of them are corn. If the president of the company selects the cereals at random, what's the probability that he selects 2 cereals that are multigrain and 2 that are corn? So we have the word and, that means that we're going to multiply. We need 2 that are multigrain and we need 2 that are corn. Now the question is, did it tell you that you're going to select, did it tell you that we're going to select one at a time? Or are we going to select them all at the same time? Does it say we're going to select one multigrain, another multigrain, one corn, and then another corn? No. It tells you that again, what's the probability of selecting 4, and whenever you go like this, at random, that you're going to have 2 of each. So if you go and select 4 of them at random, let me get one more, there you go, 4. What's the probability that you're going to end up with 2 of each? So you're selecting them all at the same time. Does that make sense? So therefore, if you select them all of them at the same time, that means that you're going to use the choose. So what's the probability of selecting 2 multigrain and 2 corn? Let's see, what's the probability of selecting 2 multigrain? How many multigrain are available? So we have 5 multigrain. And how many of them do we want? 2. And, so be it times, 4 corn are available. And how many do we want to select? 2. Over, how many are total? Remember, the denominator is not what we want. The denominator is what's possible. How many zeros are available? 9. How many are we selecting? We are selecting 4 of them. And then from there, we just simplify. Now, once you expand, just make it a little faster. 5 choose 2, that should give you a 10. If we do 4 choose 2, that should give you a 6. And if you do 9 choose 4, that should give you 126. So your answer should be 60 divided by 126. Let's see, they both are even, so divide by 2. So it gives me 30. Divide by 2, give me 63. Divide by 3 gives me 10 over 21. And that'll be your answer. Any questions? So go and start working on your homework. One of the things that I want you guys to do is that whenever you see probability, if you see probability, make sure that you highlight it. So go through your homework and first word for the word probability. If it's probability, that means that we're going to end up with a fraction. The problems that we did today. If they ask you guys to take 1, what's the probability of getting 1? Place it in your pocket and then another. Place it in your pocket and then another. That means that you're going to have 3 different fractions. If, on the other hand, they're asking you guys to what's the probability of selecting 2 red, that means that we're going to use combination. Okay, so do your best, and I'll talk to you guys next time. Have a great day.